नमस्कार दोस्तों, मेरा नाम है डॉक्टर गौरव और मैं आपका बहुत बहुत स्वागत करता हूँ मेरे यूट्यूब चैनल दयाल एंड सन्स क्लासेस ऑफ केमिकल साइंसेज में। इस वीडियो में हम डिस्कस करने वाले हैं चैप्टर वाइज सीरीज CSIR नेट की, जो हम शुरू कर रहे हैं इस वीडियो के साथ। आज वीडियो लेक्चर में हम सबसे पहले ले रहे हैं ऑर्गेनोमेटालिक कंपाउंड्स। इस वीडियो में हम देखेंगे कि हम किस तरह से वेरियस ऑर्गेनोमेटालिक कंपाउंड्स के क्लस्टर टाइप्स को निकाल सकते हैं। क्लस्टर्स निकालना सीखेंगे बेसिकली। इसमें क्लस्टर्स टाइप निकालने के लिए हमें सबसे पहले स्केलेटल इलेक्ट्रॉन पेयर के बारे में इंफॉर्मेशन पहले हमें पता होना चाहिए। SEP स्टैंड फॉर स्केलेटल इलेक्ट्रॉन पेयर्स। इफ वी नो द स्केलेटल इलेक्ट्रॉन पेयर, देन वी कैन टेल which type of cluster is this particular cluster belongs to. Now, in order to find SEP, we must know total electron count of that particular cluster. We should know the total electron count of that cluster. Now, total electron count. What is the total electron count? How can we calculate the total electron counts? That is very simple to calculate. Let's say if we have a general cluster of the type MX Ly plus N. If you have a cluster of this type MX Ly plus N type, now in order to find the total electron count for this by neutral method, we will solve this by neutral method. We will solve this particular things using the neutral method. Now, in order to calculate the total electron count for this particular type of complex by neutral method, what should we know? We should know what is the total number of valence electron of the metal M, where M is the central metal, is the metal atom, or it can be a non-transition element. Now here M can be a metal, usually transition metals, or non-transition element. It can be a transition metal or a non-transition element. For example, in this first question, which says C2B4H8, in this carbon and boron, here carbon and boron are non-transition elements, whereas in the second question, if we say Fe5 CO16 and carbon, here iron is a transition metal. Now, how to go about this? Now, if this M has valence electrons equal to M, one metal has M valence electron, then X metal of M will contribute X into M electrons toward the structure. After that, now we come to L, where L is any ligand. Let's say this L, which is a ligand, contributes L electron. Each L contributes small l electrons. Then for Y ligand, it will be YL electrons. Now plus N means, where plus N is the charge on the metal. If the charge is +1, that means one electron has been lost. So what we'll do is, we will write it at minus N. And in case if it had been minus N, then the formula would become, general formula will become X into M plus Y into L plus N. Minus N means this much electron is as are contributing, are adding up to the to form this structure. Now, I hope this much is clear. So this formula we will use to find out the TEC. Now once we know the TEC, now the thing is how to find out this SEP. Now in order to find this SEP, it has a very simple formula. In case this M is a transition element, then a skeleton electron pair is given by the formula TEC minus 12 into N divided by 2. Now here N stands for number of vertices or the metal center, vertices or the metal center or metals forming vertices or metal forming vertices. It can be either the number of N you can replace N by either by the number of vertices or by the number of metals forming the vertices. Now, and if M is a non-transition element, then formula for SEP becomes TEC minus 2 into N divided by 2. This is a general formula that you can use for find out the cluster type of not only the transition metal clusters but also the carbonic clusters, carbonic or non-carbonic or other inorganic clusters, structure type of other inorganic clusters. Now, so I hope this much is clear. Now let's see. Now let us calculate for the first one, that is this is C2B4H8. What we call this type of compound? This type of compound are called carboranes. This question has been asked in December 2012. Let's see how to solve this question. Now, before solving this, now let's see how this SEP will help us in finding out the cluster type. For finding out the cluster type from SEP, we use Waday's rule, what we call as Waday's rule. We use the Waday's rule. What does the Waday's rule says? If the skeleton electron pair, if SEP is equal to N plus 1, the cluster will have Closo. If SEP is equal to N plus 2, it will be Nido. If SEP is equal to N plus 3, it will be Arachno. If SEP is equal to N plus 4, it is Hypho. And if SEP is N plus 5, it is called Klado. There is one more. If SEP is equal to N, implies Hypercloso, it will be called Hypercloso. And if SEP is equal to N minus 1, this means Supercloso. It will be Supercloso or Superhypercloso. Alright. So once we know the skeleton electron pair, then by comparing with this rule, that is if it comes out to be N plus 1, skeleton electron, that is number of vertices plus 1. Here N is again the number of vertices. If we get number of skeleton electron pair equal to be number of vertices plus 1, then it is a closed structure. If this number of electron pair is N plus 2, that is number of vertices plus 2, then it is Nido. If number of vertices plus 3, then it will be Arachno. Similarly, N plus 4 will be Hypho, N plus 5 is Klado. But if it is N, if skeleton pair come out to be the number of vertices, then it is called a Hypercloso. and if come out to be 1 less than the number of vertices, then we will call it supercloso. Now let's begin for finding out the skeletal types. Just note this rule quickly, then we move, then I erase it. Just pause the video and note this down. Okay, let's begin with the question now. So in short, I write down here the formulas. SEP is equal to TEC minus 12 into N by 2, or SEP is equal to TEC minus 2 into N upon 2 for transition, non-transition, and N plus 1 Closo, N plus 2 Nido, N plus 3 Arachno, N plus 4 Hypho. So these are the formula that we are doing. So these formula we are going to use in this particular question. Now let us see. We have first compound is C2H4, C2B4H8. C2B4H8. Now in this case, total electron count TC will be equal to, carbon has 4 valence electron, 4 electrons, into, there are 2 carbon, so it will be 4 into 2, plus 1 boron has valence electron 3, or 4 electron, it is 3 into 4, we will write 3 into 4, 1 boron contributes 3, and there are 4, that's why we multiplied by 4, plus, now there are 8 hydrogen, 1 hydrogen contributes 1 electron, 1 into 8. This have come out to be 8, 8, 16, 16 and 12, 28. It come out to be 28. TC comes out to be 28. Now SEP. Now here these all elements are non-transition, and the number of vertices will be 2 plus 4. Both carbon and boron in this case will be forming the vertices. So total number of vertices becomes 6. So the SEP becomes TEC minus 2 into N by 2. TEC is 28. Number of vertices are 6 divided by 2, that is equal to 7. And this 7 means it is an Closo, implies it will be a Closo. So it will form a Closo structure. It will have a Closo structure. This implies SEP is equal to 7, so we can write as 6 plus 1, that this is, and number of vertices plus 1 implies Closo. Therefore, this particular carborane will have a Closo structure. I hope this is clear. Now let's see the second question that is asked in June 2014. It is asked in June 2014. It says find out the cluster type of Fe5CO 16C. Now here again TEC equal to iron. Iron is the 3d6 element. Iron has 8 valence electrons. It has a configuration 3d6 4s2. The total valence electrons are 8 into 5. We have 5 iron, so 1 iron contributes 8. If they are 5, we are going to multiply it by 5 plus carbonyl. Each carbonyl contributes 2 valence electron. Each carbonyl CO contributes 2 electron. So we get 2 into 16. There are 16 CO, so we will multiply 2 by 16 plus there is 1 carbon, and carbon I have already told you that it will contribute 4 electron. So we write down here 4. Now let's see, is equal to. Now here one thing to note, here carbon will not form the vertex. It will lie in the interstitial space. It will be in the interstitial. It will not form the vertex. So therefore in this particular complex, in this particular cluster, the number of vertices will be 5. Alright. Now let's calculate this. 8 5 is 40 plus 32 plus 4 come out to be 76. It's come out to be 76. TC 76. Now let's see how much is SEP are there. SEP is equal to, now here iron is transition element. So what we will write, TEC minus 12 into N. That is 76 minus 12 into number of iron 5. What is this 5? Divided by 2. That is equal to 16 upon 2. It will be form 76 minus 60 is equal to 8. And this come out to be SEP is equal to 8. This is equal to, this we can write as 5 by 3. This means N plus 3, and N plus 3 denotes Arachno. So this will have Arachno structure. So this particular cluster will have Arachno type of cluster symmetry. I hope this which is clear. Just quickly note this. Okay, now we move to next question. Question 3, this was asked in June 2015. Here we are given the 3 clusters and we were required to find the cluster type of each of these clusters. What are these? First one, let's take first one, RU6 C CO17. Now TEC again, RU Ruthenium, it's come below, its RU lies in the same group as iron, so it will have 8 electrons. 8 electron. There are 6 RU, implies 8 into 6. There is 1 carbon, it will contribute 4. Plus there are 17 carbonyl, each carbon contributes 2, therefore 17 will contribute 2 into 17. This come out to be 48 plus 4 plus 34. 48 will become 86. It will come out to be 86. TEC will be 86. Now let's see SEP. SEP will be equal to 86. Total valence electron 86 minus 12 into N, 12 into 6 divided by 2, that is 86 minus 72 upon 2, that is equal to 7. 14 by 2 equal to 7, implies this will be a Closo. This one will be Closo. Implies this one will be Closo. I hope this is clear. Now let's see the second one. Now let's take the second one. Second one, it says OS5 C CO15. Now here osmium is again is below ruthenium. It again contributes 8 electron, 8 into 5, there are 5 CO, that is 8 into 5. For carbon 4, 15 CO will contribute 15 into 2, that is equal to 40, 30, 34, again 74. It will come out to be 74. SEP will be equal to 74 minus 12 into 5, 60, divided by 2, again it will come out to be 7. But here this is equal to 5 plus 2, that is implies n plus 2, and n plus 2 means Nido, imply this is Nido. This will be Nido. This will be Nido. I hope it's clear now. Now let's check the third one. Let's check the third one, which says Ru5 C CO16. Ru5 CO16. Alright. Now let's check for this one. Ruthenium 8 electron for 1, for 5 it will be 8 into 5 plus 4 plus 2 into 16, this will come out to be 40, 32, 76. This will come out to be 76. 40 or 32, 40 or 36, 40 and 36, 76. TC will be 76. SEP will be equal to 76 minus 60 divided by 2, 12 into 5. We have 5, 12 into 5 is 60, the 75 minus 60 divided by 2, that will come out to be 16 upon 2, that is equal to 8, which means 5 plus 3, which means n plus 3, and n plus 3 is Arachno. So first complex was Closo, second was Nido, and third was Arachno. Alright, I hope I'm clear. I hope everything is clear now. Alright. Now let us take up the fourth question, which is again from June 2015. Which is again from June 2015. Now in this question what we are given was, we have to find out the cluster type of B12H12 2 negative. Now here TEC is 1 boron contributes 3 into 12 plus 1 into 12, there is minus 2, that means it will come out to plus 2. Now what we have said in the previous formula, that if we have a negative charge then we add that charge, and if we have a positive charge then we subtract that from the total valence electrons, is equal to 36 plus 12 plus 2, this come out to be 1450. It come out to be 50. Now SEP is equal to 50 minus 12 into 2 divided by 2, that will come out to be 26 upon 2, that is 13, which is implies SEP is equal to 13 and is equal to 12 plus, we can write it as 12 plus 1 is equal to n plus 1, implies Closo. This will be a Closo. This will be Closo. Alright. Rather, you can straightforwardly also know, remember this, if we have a system like BnHn 2 negative, it always be a Closo. So if we see here, it is B12H12 2 negative, it is BnHn 2 negative, is always a Closo structure. Always remember this. Okay, now we come to another question which was asked in December 2019, and this question most of the people got it wrong. Why? Let me tell you why. Let's write down the clusters which were asked: FeCO, negative, and CO6, CO13 and negative. We were given these two clusters and we were asked to tell the cluster type for these two particular compounds. Now let's see how to calculate this. Now for this TEC, now here what the people took wrong was they counted 3 electrons for this nitrogen. Please do remember, when nitrogen is present with more than 2 metal atom, the nitrogen is usually present in interstices, and when an element is present in interstices, it contributes all its valence electron. So valence electron for nitrogen are 5. Nitrogen has 5 valence electrons. That all that 5 electrons, those 5 electrons will be contributed towards this skeletal structure. Therefore, while counting the total valence electron, what will have for iron? 1 iron contributes 8 into 5. Each carbon contributes 2 into 14, and 5 electron for nitrogen. And there is 1 negative charge, that means plus 1. Now, why I have written 5? Because here it is a multi-nuclear cluster. In multinuclear cluster, nitrogen is always present in the interstices, and when it is present in the interstices, it will contribute all its electrons toward the structure. And therefore, and since N has total valence electron in nitrogen is 5, so it will contribute all its 5 electrons in the formation of skeletal structure of this particular cluster. Therefore, we are taking the electrons as 5. Now let's see what comes to be total electron. 40 plus 28 plus 6, 34, 74. This come out to be 74. Now let's calculate SEP for this. What will be the SEP? SEP will be 74, total valence electron 74 minus 12 into N, there are 5 electron, 5 ions and 5 iron, that means 5 vertices. 5 vertices means 12 into 5, 12 into 5 is 60, divided by 2, this will come out to be 7. This come out to be 7. This implies, we can write it as 5 plus 2, and N plus 2 is Nido. So this particular cluster had Nido structure. This one has Nido. This one is Nido. Now let's calculate for the second one. For CO16, CO13, again CO 6 into 8 plus 2 into 13, 2 electron 1 carbonyl, 13, 2 into 13 plus 5 and negative charge plus 1 is equal to 8 6 is 48 plus 26 plus 6, 52, sorry 32 of this will come out to be 50 30, but this 8 into 10 80, TC will be 80. Now what we will do is SEP is equal to 80 minus 12 into n divided by 2, n is here 6 means 72, check out, oh sorry cobalt का 8 नहीं है, sorry cobalt is not 8, my mistake, cobalt does not contribute 8 electron, that's my mistake, cobalt contributes 9, 54, 32, 86, 14 by 2, that is equal to 7, this will come out to be 7, sorry cobalt will contribute 9 electron, 1 will contribute 9, there are 6 here, so 6 into 9, alright, this will come out to be 86, the 86 minus 72 will give 14, 14 divided by 2 will give 7, and 7 can be written as 6 plus 1, that is equal to n plus 1, that means this has a Closo. So the first complex, that is a iron complex, has a Nido structure, whereas cobalt one has a Closo structure. So this is all for the today's video. We will continue with this in the next video that will be coming soon. So stay tuned. If you like the video, please do subscribe my channel. Thanks for viewing it.